Okay, so we are starting. Hello, everyone. Do you hear us? Do you see us? You can comment on the chat, so that would be helpful because we don't want to be explaining something here and at the end you don't hear it or you don't see it. In case you don't hear, the left top corner, by default, I think it's turned on the mute button. So if you press the button, you should hear us correctly, let's say. I see 8 people at this moment.
It's funny because I cannot find any place in this window where I can just count the audience somehow. Maybe it's better that I am unaware.
We have 9. I will, maybe I will just put a banner. If you can't hear, mute top left corner. Pa, 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 pa. Okay. That was the once we were testing this, that was the main issue that we had. First comments. Hi, hello. Video is clear. Audio sounds great. Perfect. Thank you, Matthew. Thank you, Grzegorz. So I think we can start. Okay, so I will tell you more or less about me, about our speaker today, how we're gonna proceed, what you can do later on, and at the final, we're gonna have like QA session, so you can put your questions. Of course, if you have any doubts during the whole presentation, you can stop us anytime. I'm gonna see your comments anytime. Okay, so I'm Adam. I'm member of the Polish Blockchain Association, in the role of the project coordinator. What we do here is basically spread the good knowledge about the blockchain technology in general. We also try to do our best in coordinating this kind of events, not only webinars, but also meetups. We are open to any collaboration. So if you want to contact me or anyone, you can do it on our page. You can find us on Facebook, on Twitter, on LinkedIn. I think the LinkedIn is the most important one, where we have most content. And what else? Today here we have Valdemar. Valdemar gonna start with the first of, I think, 4 meetups or webinars about how to program a smart contract. We're gonna have those webinars between 2 weeks, so stay tuned if you're interested. And what else? I think that's it. I left to speak Valdemar about present himself, so I will shut up and let him talk. Go ahead, Valdemar.
Thank you, Adam. Yeah, basically I will try and do my best. Okay, so my name is Waldemar Trawnicki. I'm working currently in the GFT since 2016. Recently focused more or less, mostly on the blockchain area. But that was not the first, let's say, area which I was, let's say, working within the GFT. But funny thing is that I started this blockchain adventure at 2017, to be honest, with the project where I was when I was just working on not the public blockchain, but here, there was the first time when the distributed ledger technology was introduced by Corda at that time. Yes, so basically that was my first let's say contact with the DLT technology and further on the blockchains. Yes. Now mostly we are interested in the collaboration between connecting the two both worlds. So I can see that the DLT, so distributed ledger technology, is more or less used mostly by the financial institutions, yes, where the privacy is most important thing. But the institutions are also interested in earning some money by using the public blockchains, yes, where all the tokens are currently let's say lived there. So basically they just very interested in let's say taking a piece of that cake, yes, for themselves. And yes, so that's why probably I'm here, yes. And I would just try to maybe pass you some part of my knowledge, part of the, let's say, this very special world which let's say needs from us as a blockchain developers special state of minds, because this is not the general programming, let's say. Yes, as a blockchain developer, we need to just think more or less in the block way, yes, because we have some final time in order to process some logic, and this logic should be processed during the block creation. Nevertheless, the agenda for today is to just start with the very basics. I would just try to give you an overview about starting from the blockchain, then a little bit information about the different types of the consensus mechanism, and way of how the information is stored and maintained in the blockchains. Later on, some information, some more details about the mechanics of the Ethereum virtual machine. And the last part would be the presentation of development environments, yes, how to use it, yes, how to program the smart contracts there, how to test it, and how to at the end deploy on the test or the mainnet. And at the very end, some real coding and maybe some information, small piece of information that there is no, that this world is not, is not, let's say, it's not safe for us as developers, because each mistake can just cost us on the mainnet at least a lot of the money. Yes, and there are a lot of the entities, I don't know, persons, bots. We are just waiting for your mistakes. Yes. Okay, so let's go with the presentation. So on the first slide, as you can see, there is a quote with the definition of the blockchain. And essentially, this is this couple of sentences just describe the essence of the blockchain itself. Yes, why the blockchain was introduced, what is used for. Yes, what are the pros, and there is no cons, at least. Yes, but from my perspective, there are lots of the pros which are needs to be let's say loudly underlined. Yes, that the blockchain is the best solution for the distributed let's say financial world or distributed solutions. Yes, but yes, it's worth to let's say comment or just say that of course the blockchain, as probably everyone knows that the blockchain is decentralized. Yes, ledger technology, and this is the very important stuff. That is the main purpose, to record and verify in a secure and transparent way all the transactions. And the most important stuff is that there is no need of the central authority. Yes, so this is something which is the most important let's say aspect of using the blockchain. Yes, so no need of the central authority. Yes, so the key advantages here, as of course very let's say important stuff for the financial institutions, the transparency and security. Yes, and as here is mentioned, this idea for application where the security and trust are very important. Yes, there's a saying that there is also additional pros, that it is reducing the cost of improving the efficiency by eliminating the need of let's say third party. Yes, and central authorities. And to be honest, that's true for the as example, I can say that the mentioned by me, the first project which I was involved, where we just create the solution for dozens of banks in Italy. Yes, there was a project which was about improving the process of factoring the invoices. Yes, and because we just use the decentralized technology. Yes, we use the Corda, so there was no need of the central authority. We just connect all of the banks to one single network. Yes, they share the information between them in a secure way. So I can say that the entire process was, let's say, shortened from the 2 weeks before to only 2 hours. Yes, so it means that for sure it is reducing the cost. Yes, and improving the efficiency of some type of the solutions. Okay, let's go to the next slide. Okay, so let's maybe go deep dive a little bit in the details how the blockchain network is working. Yes, so basically we have currently the two types of the mechanism which are responsible of managing or storing the states. Yes, so on the left side, I just mentioned about the UTXO model, which is mainly used by the Bitcoin and Bitcoin-like networks like Bitcoin Cash and Litecoins. Yes, this is the UTXO model, and UTXO stands for the unspent transaction outputs. Yes, which means that each transaction so each transaction is just consuming the unspent transaction outputs which were previously created by the past transaction. Yes, just use them, and at the end let's say create the completely new outputs. Yes, so on the other words, it is just consuming, yes, the unspent ones, yes, and at the end create the completely new states which are unspent and ready to be spent on the following transactions, yes, registered in the new blocks, yes. And this is how I just put here the icon of the money, yes. This is the because this is the good example and good, let's say, something which we can just correlate to the real world, yes. So basically we can just track the unspent transaction outputs as let's say banknotes, yes. So for example, if Alice want to pay Bob, I don't know, 50 euros, yes, and she has the unspent transaction output worth 100 euros, for example, yes, or let's say bitcoins. Let's say bitcoins, okay, because I would just focus on the Bitcoin network. So Alice would like to pay 50 bitcoins to Bob. She has the unspent transaction output which belongs to her, yes, with the 100 bitcoins on it, yes. So basically, the transaction looks like that the transaction is consuming her state, yes, this 100 Bitcoin unspent transaction, yes, output coming from the previous states, yes, just spend it. In other words, just create based on that that unspent transaction output, create completely the two new states, which one of the state will be just assigned to the Bob with the value 50, yes, and the change for that transaction, yes, is creating the completely new state which is still assigned to Alice, yes. So from one unspent transaction output, yes, the Bitcoin transaction creates two new ones, yes. And this is how the payments in the Bitcoin network works, yes. On the other hand, we have the Ethereum-like blockchains, yes, where we cannot say that there is a kind of unspent transaction output, yes. This is the different approach, which is called the account-based model, and it is more or less like managing, huge Excel file, yes, where, for example, all balances of all accounts are, listed in particular rows, yes, and each transaction is just changing constantly the values on this Excel cell, yes, updating the values because of the transactions, yes. So this is the difference, yes. This results with the more flexibility, let's say, which I can just then comment the next slides. But now I would like to just switch to the consensus mechanism. Yes. Why we need the consensus mechanism in the blockchains? We need the consensus mechanism because the first of all, what we need to prevent is the possibility to do the double spend, yes, because this is the most important stuff. So double spend means that we cannot allow user or the customer in financial world to just use the same, I don't know, cryptocurrency or the same, information twice, yes. So basically, consensus is used to prevent such a double spend, which would be just the frauds, yes. So again, I have the split into the two different types, yes. Again, on the left side, we have the Bitcoin. On the right side, we have for example, Ethereum, yes. So the Bitcoin is still using the proof of work, which means that it is, not very, maybe I can say not maybe efficient, but okay, it's not efficient. Yes, it's very, very expensive. Yes, in current days where the energy is, the price of the energy is quite high. Yes. So the proof of work also requires from the miners. Probably you have heard about the miners, what the miners are. So basically, this is the part of the network which is responsible of mining the transactions and put them into the blocks, which results in creating the additional blocks and added to the blockchain itself. Yes, and in the proof of work, in order to add some new blocks to the chain, yes, the miners needs to solve the complex, let's say, puzzle. So it means that they need to calculate the hash of the block, which means that they need to find the correct hash. Correct hash means that the hash needs to have arbitrary number of zeros in front of the hash. Yes, and the number of zeros here in this proof of work are just let's say define the difficulty of this complex algorithmic let's say calculation. Yes, and the difficulty is also, let's say, changed in order to prevent in the Bitcoin the situation that the blocks are created more frequently than one per 10 minutes. And the 10 minutes was let's say set because that time is needed in order to spread the information about the block through entire network. So it means that there is some particular difficulty parameter set. Yes, if for example the blocks are for some of the number of blocks are generated more frequently than 10 minutes, the difficulty parameter is, let's say, changed to the more let's say more just that is adjusted. Yes, to adjusted means that there is a need to find the hash with more zeros at the beginning than it was before. Yes, so this is how the Bitcoin is maintaining its let's say the time, the consensus. Yes, and the time needed in order to preserve this consensus within the network. Yes. On the other hand, we have the Ethereum network, and recently the Ethereum network switched the consensus mechanism from the proof of work to proof of stake. And right now there is no complex algorithmic, let's say, calculations needed in order to add the blocks to the blockchains to the blockchain. Now the concept is that there is a set list group of validators, yes, which are staking their Ethereum cryptocurrency in order to, let's say, be able to broadcast the new created blocks to the network. And why they need to stake? Because there is a need to ensure that the validators are, let's say, honest, yes, and does not act in the bad way, let's say, do not allowing to do, for example, double spends. Yes, so basically, if some of the validator just acts not honestly, so the rest of the validators are easy to just point such a bad validator, and because of this fact, the validator then which act not honestly is, let's say, punished by by the network and it's staked Ethereum cryptocurrency. Part of it is just taken away from him. Yes. So this is how the proof of stake more or less working, and how the consensus mechanism based on the proof of stake preserve the consensus in the blockchain. And okay, let's go move on. So the next slides just present the flow, how the flow looks like in order to add the from the starting point by submitting the transaction by the client, by the user, yes, till the submitting the block and add the block to the blockchain. So the first step is the fact that the transactions are submitted, yes, by the users, and further on by the nodes, yes, because the user normally is not able to just directly connect to the blockchain itself. The component which is used to communicate directly with the blockchain is the node, yes. So the next step, the node must ensure that the transaction is correctly prepared by the user by checking the signatures, yes, and verify its validity and the fact that the transaction is coming from this particular user, yes, and yeah, and this the next step is to check the basic parameters, like for example, if the user has enough funds in order to send it to some value shown in the transaction to the next user on his balance, yes. Okay, so the next step is the formation of the block. So the validated transactions, yes, are grouped by the node in the form of the block, yes, and again the block needs to be equipped with some additional information like the hash, yes. So the node is calculating the hash for the entire block. Also put some additional information like the timestamp, yes, and all the stuff needed in the header, yes. And also the most important thing, which let's say is connected also with the blockchain, is that within that block, it is also putting the hash which points to the previous block, yes. Okay, next, the third step is a mining. Or maybe just it's worth to mention that. Let me just go back to this stage 2. So basically, we can ask how the block formation looks like. Yes, is there some of limitation? And in fact, there is. So, for example, the Bitcoin has a limit of 1 megabyte per block. Yes, so it means that it can contain approximately 1,000 or 2,000 transactions per block. Yes, so every 10 minutes. So this is the performance of the blockchain network. Yes, so at top, we can just put there 2,000 transactions. Yes, so 2,000 transactions per 10 minutes. So this is the maximum performance of the Bitcoin like blockchains. Yes. For the Ethereum, there is no concept of the max block size. There is a concept of the maximum gas which can be spent or can be used by the block. Yes, and for the block. For the Bitcoin, there is a limit of starting from the 15 million to 30 million gas units per block. So this is also the difference between the UTXO blockchains and for example the Ethereum ones. Yes. Okay. So the third step is the mining. Yes. So the mining is the moment when the miner is trying to in the blockchain, in the Bitcoin blockchain, is trying to solve that puzzle. Yes, algorithmic puzzle. It's trying to calculate the correct hash with the correct number of the zeros in the front of it. Yes. And in the Ethereum, for the instance, there is just collecting the block, the transaction into the block, and just trying to broadcast the transactions, yes, to the network in order to the block added, yes. And of course, there's also a moment that the node is responsible for calculating the hash in the honest way, yes. And this is exactly the moment when the nodes can let's say the miners can take advantage of the fact that there's normally the number of transactions is much larger than the block can handle. Yes, during this period of time when the block is creating. So this now we can say that the concept of transaction which can stack can happen here. Yes, because in the blockchain during the transaction, the submitting transaction, the user is always giving additional information that, for example, in the Ethereum, he's willing to pay that much gas at that price. Yes, so it can, let's say, differentiate between the similar transaction submitted by other user. Yes. The user can, the second user can just is willing to pay less by processing such a transaction by the miner. Yes, so in that moment we can just as a users, yes, we can just a little bit enforce the miners to choose our transactions among the other ones which are waiting in the mempool. The mempool is the place where all transactions are waiting for being, let's say, picked up by the miners and put into the blocks. Okay. So the next phase is the verification. Yes. So once the miners solve the puzzles, yes, for the blockchain and for the Ethereum, when the blocks are created, yes, so the transaction chosen by the miners are taken from the mempools and put to the block. Yes, the block is normally broadcasted to the network, where the rest of the nodes are responsible of verifying if the correct hash was calculated based on the data which the block contains. Yes, if everything looks fine from the verification perspective, yes, the block at the end is added to the blockchain, and by that we are just having the additional chain, the block in that chain, which will just form the new version of the entire blockchain. So yeah, so this is the way how the flow more or less looks like. I encourage you guys, in order to, if you have any question, just give me a comment. Yes, I will just maybe stop and focus on some aspect. Okay, so Let's go to the next slide and think about how the block itself is, let's say, constructed, yes, and why we can just say that this is the blockchain, yes, as I mentioned before. So normally the block on the very high level of abstraction always have a header, yes, and the body, yes. The header contains the block number, the hash of the previous block, the nonce, sometimes the nonce, more or less in each of the blockchain, the creation timestamp and the hash, yes. And in the body contains all the data which were just added by the miners. I mean the transactions or all the interactions with the smart contracts, for example. Yes, and the most important thing here is that we can say about the blockchain, because as I mentioned here, the header contains the hash of the previous block, which allows us as let's say users to just go back and, for example, check what happened, let's say with, or maybe on the other hand, check what is the origin place, for example, from where the coins are, let's say, just were sent to us. Yes. So this is the blockchain. We have always the hash to the previous block, so we can just and this is connected strictly with this transparency. Yes. So this is very important, for example, for the AML processes. This is the anti-money laundering processes, which banks needs to use in order to, for example, allow some customers to get the receive operation. Yes, these AML procedures normally just are involved in the tracking the origination of such a transfer. Yes, so by using this mechanism that each new block contains the pointer to the previous one. Yes, so we can just track the money and its origination. Yes, the place where was the send coming from. Yes, if it was for example, from the known account which is connected with some, I don't know, drug, let's say, dealing entity or stuff like that. Yeah. Okay, so now this is time to focus on the EVM, because I will just now continue the meeting about how to create the contract using the Ethereum network. Yes, so that's why maybe it's time to just deep dive a little bit with the EVM and what is the under the hood. Yes, how the EVM is constructed. Okay, so the EVM. What is the EVM? EVM is a virtual machine. This is the first statement. Yes, this means that virtual machines provide a runtime environment, but are completely platform agnostic. It allows compatibility across a wide variety of systems, yes, irrespective of the underlying hardware. This is very important in the world of the Ethereum, yes, because there is no need to have the special software, I don't know, architecture. Yes, there is no need to run this EVM only on the, I don't know, Intel processors. Yes, there is so by using the EVM, it means that we can just have the different implementation of the nodes, which can be run on the different operating systems. Yes, starting from the Windows, ending with I don't know, starting with the Intel. Yes, so and ending with the ARM processors. Okay, so next sentence, that the EVM is the state machine. Yes, so the state machine, in a very simple terms, is a device that specializes in storing state as well as defining the rules of state changes of particular system. So it can change or transition, yes, its state from one to another, depending on the inputs provided to it. Yes, so this is very important aspect of the EVM, which, let's say, makes it more flexible and it enforces the usability of the Ethereum, comparing, for example, to the Bitcoin. Yes. And the next sentence, the quasi-Turing complete machine. Yes, and why I name it quasi? The quasi means that, of course, this machine, this Turing complete machine, yes, enable running the program, and the list of instructions. You can solve any computational problem, yes, irrespective of time or memory it takes to do so. This is the description of the Turing complete machine. Why I use the quasi? Because of the time factor. Yes, we cannot allow such a virtual machine to work endless. Yes, we have some particular time period where the transaction can be processed. Yes, and no longer than that. Yes, so that's why there is a quasi. Yes, so we cannot because we cannot enforce to just break this this processing operation by, I don't know, pressing the Control and C. Yes, so it means that we need to have some mechanism which just preserve such a let's say, just do not allow to such algorithms working endless. Yes, so that's why now I'm just maybe introduce the term gas. Yes, the concept of the gas, and the concept of gas is the something which is connected with the processing mechanism. Yes, each of the instruction processed by this Turing complete machine costs some amount of the gas. Yes, and which means that we cannot endless do just perform some loop. Yes, because at some period of time we just burn all the gas which are available for this processing transaction, processing transaction. So basically, this will just break the computation and end up with the out of gas exception, which allows to just break such a long period time operation and just move on to the next transactions. Okay, so next is the architecture of and its components of EVM. Yes, so EVM is constructed, as you can see, with contains the machine state, which can be, let's say, divided to the stack, memory, program counter, and the information how much gas is still available. Yes, it is also has access to the storage. Yes, of some account which is currently under the process, And of course, we have some EVM virtual ROM with the EVM code. Yes. So the storage can simply be understood as a permanent storage of EVM. And the value that is written to the storage is preserved, yes, even after the execution is completed. So in the simple terms, the storage is basically a key value storage system that maps 32 byte slots to 32 byte values. So this is the storage, yes. EVM memory, on the other hand, is not really persistent and is cleared out as soon as the execution is completed. It's quite, there's also, within the memory can also just mention about the call data, which is the interesting section of the EVM. And it is something which is a part of the each of the transaction, yes, and can be used as a, let's say, cheap way of sending the data, yes, to the contract. But it is read only, yes, so we cannot change the values which are part of the call data. And okay, so the counter here, which I mentioned, is a special part of the Ethereum EVM, yes, because this is the EVM technically is a stack machine, yes. It is just maintaining continuously the stack, yes, and the stack is updated based on the instruction which are creating the entire program, yes, which is executed by the EVM. And so the program counter is just the counter which instruct the EVM to just move forward, yes, by one to the next instruction from the previous one, yes. Okay, maybe later on I will just show you how the counter is working. Okay, so EVM, let's say, in action, yes. So I think that you probably know how the transaction looks like, more or less. So this is the JSON representation of the transaction. Yeah? So basically, this is very simple interaction with, I believe, the smart contract. Yes, we have the information that the transaction was originated from particular address listed in the from. Yes, the information is also about which smart contract is the transaction interacting with. Yes, it's listed in the property too. We have also the information. Each of the transactions should have the information of the gas limit. So this is the exactly the parameter which I just mentioned about this quasi-Turing complete machine. Yes, so this is the information how much gas we as a users just are, let's say, able to spend. Yes, and additional fields like the max fee per gas and max priority fee per gas. That is something which allows us as a users to just makes our transaction more attractive for the miners. Yes, so this could allows us to ensure that our transaction will be picked up faster than the other ones which are currently in the mempool, because we are just willing to pay a little bit more than the others by using the special gas prices value. Of course, we need to put the nonce. Maybe we can just put the value here this is the value of the Ether, yes, and the data is the data which is exactly contains the encoded transaction values. Yes. So this is the more or less how the transaction looks like, the Ethereum one. Yes. Maybe it is worth to mention about the nonce parameter here. Yes. This is very important. This is a very important parameter which allows Ethereum network to be not able to just preserve the users and the network to do the double spends. Yes. So it means that, for instance, if you are just having your own wallet, for example, the Metamask, yes, so you are just having your own wallet within the browser, you have some Ethereum on it, yes, and you would like to just do some transfers, yes. So let's imagine that this is the very first transfer which you are trying to do. So basically, the nonce for the very first transaction should be always set to 0. Normally, the nonce and is maintained by the wallet itself, yes, and it is automatically incremented, yes. But we as a developers need to be aware about this nonce, because wrongly used value of the nonce can just end up with the situation that our transaction can stuck in the mempool. Yes, mostly because, for example, you are just choosing to not maintain it automatically by the wallet, by you arbitrarily put the value there by some, by your software. Yes, so for example, the transaction can stack very easily in the situation when, for example, you are just prepare the first transaction with the non-zero, yes, and this transaction will just let's say stay in the mempool waiting for being added to the blockchain to the block, yes, by the miners. And the next what you just trying to do is to put the next transaction, but not with the nonce 1, but with the nonce, for example, I don't know, 10. Yes, it will result with the situation that the miners will never just pick up the new transaction with the nonce equal 10, because there cannot be gap between the transaction which was previously submitted by you and the new one. Yes, so such a transaction submitted with the nonce 10 will be still waiting in the mempool as long as you not fill the gap, yes, between the 0 and the 10. Yes, so the blockchain will be just waiting for the additional 9 transactions, yes, which will fill the gap. And after that, when the transaction with the nonce 9 will be made, the transaction with the nonce 10 will be picked up by the miners. Yes. So this is the nonce is quite important parameter which we need to be aware. Yes. Of course, it also helps a little bit with in the situation that, for example, the transaction will stuck in the mempool because of the low gas price. Yes. And it is completely, and such a transaction is completely not, let's say, attractive for the miners. Yes, so in the mempool, the miners can, in such a situation, can easily find the more attractive transaction compared to yours. Yes, and that's why the transaction is still hanging. Yeah? Will be still hanging in the mempool, waiting for being executed. Sometimes even for the days. Yes. So having in mind that the nonce is the thing that is used during the submitted transaction, yes, we can just use this this information, this knowledge, and, for example, update such a transaction, yes, or cancel this transaction, yes, in order to on one of the on one side of the hand, you can just speed up the transaction, or you can just maybe choose to completely cancel it. Okay, so let's move on. So how the EVM is executing the code, yes, of the transaction. So as I mentioned on the previous slide, there is a two field, yes. So basically, the first step, the EVM initialization, is responsible for, let's say, checking or the checking. So this is taking the value which is assigned to the two parameter, yes. And in case if that is the address of the contract, yes, the contract, the EVM is trying to pull that information, to pull the code, yes, from the Ethereum blockchain in order to just initialize all the structures with the code needed to just process such a transaction, yes. And additionally, the transaction also the EVM is initialized with the additional parameters which comes with the transaction, like the gas limit, yes, ether value, yes, and as well as the data that should be executed on the target contract. The next step is the EVM preparation, yes. So as I mentioned, the code should be already pulled from the Ethereum network to that EVM machine into the stack. Yes, so the stack is initialized. The program counter here is set to 0, and the next step, the execution is starting. Yes, starting, and then. And this means that the code pulled from the smart contract address, of course, containing some instructions, yes, which are just processed by the EVM, resulting with the successfully processing or just rejecting the transaction because of some problems or some issues, or for example of the fact that there is not enough gas left for the state machine and for the further instructions to be processed. Yes, and exactly the EVM, this step is burning the gas, so this, reducing the gas amount, which allows to, for example, break the execution for the long living operations. Yes, and maybe here I can just show you how the EVM is working using showing you the remix. Yes, so maybe I will just share stop sharing the presentation. I will share my screen then. Okay, so this is it. I will talk about the remix in the next. Just describe the remix in the next slide. Yes, but nevertheless, as I know, the very brief information about that is the most easy way to just start adventure with the coding the smart contracts. Yes, because this IDE is completely embedded within the web browser. Yes, so you do not need to download anything. You can just start playing with the Ethereum, just having the Chrome, yes, and nothing else. So what I would like to just maybe show you is exactly how the EVM is processing the transaction and how the, let's say, components are let's say, more or less looks like. Because maybe also I will just tell you additionally about something about the code itself. Yes, so basically this is how the smart contract looks like. Yes, so on the screen you can see the example of the basic token implementation. Yes, it's more or less implementation this of ERC20 contract. Yes, and of course you know that we can use the mostly adopted language to write the smart contract for the Ethereum is the Solidity language. Of course, we can use the Python and for this purpose. Yes, but I will just focus on the Solidity here. So basically, we are just as a developers using the Solidity in order to encode some logic, yes, in order to construct the smart contract, yes, which can be deployed on the blockchain and then later on executed by the EVM, yes. But how EVM is understanding this logic, which is written in high abstraction language, yes, not completely understandable by the EVM, yes. So basically, what Solidity compiler is doing is compiling such a source code, yes, into the form of the bytecodes, yes. The bytecodes means that there is a more or less machine, let's say, but maybe not machine because it's not a instruction of the processors, but this is instruction of the virtual machine, the Ethereum virtual machine. So basically, from this representation, the compiler is just creating the bytecode, yes, which is a set of the instructions which are using the opcodes. Yes, the opcodes are the basic instructions which is understood by the virtual machine itself. So there is around 130 total unique opcodes, yes, at the moment, and of course each has a specific functionality attached to it. Okay, so I can show you how the EVM is processing such a smart contract. So let me just maybe first of all compile this token. So maybe, okay, this is the basic token. This is compile. Let me just deploy it. So not this one. Okay, and as I mentioned, yes, this is the basic implementation of the ERC20 contract. So I just in the previous step, I just quickly compiled this, which result with the generation of the bytecode, yes, which later on can be deployed on the let's say blockchain here. I'm not currently using the real blockchain. I'm just using the embedded, let's say, mock of the blockchain within this Solidity, this Remix, sorry, IDE. Yes. So deploying the smart contract here, I have its own address. Yes, so it was deployed on this address 0xd91 something. Yes, in the memory. And here we have access to all the functionality of that smart contract. So we have the three functions: the approve, transfer, and transfer from, and some of the read functions or the just properties. Yes. So for example, we can just read what is the name of the token. Yes. So this is the my token. What is the symbol? What is the total supply of it? and how and decimals we have on it. So, but this is not what I would like to show you. So maybe let's do let's do a simple transfer, which then we can just debug and see how the EVM is processing such a transaction. So let me check how many tokens I have here. So basically, I have it's 10 or more accounts which are available in that mock. So let me check how many tokens we have on that account. Sorry. So let me just check the balance of my address. Okay, so I have 1 million of it. Let me check the second account. I expect to have the 0, but let's check in fact that this is the true. Yes, we have the 0. So let me maybe do the transfer from this first account, which has some balance, to the second one. Okay, so let me just do the transfer to address. This is the second address, and let's say I just would like to have one of it. So I have the 18.0. So maybe let's put some number of zeros here, and let me just execute that transaction. So we have the transaction executed here. Yes, let me just maybe double check if I have some balance right now. As you can see, yes, from the 0 is changed to the some value which I put here during the transfer. Yes. So what I would like to just now show you is how the transfer is executed by the EVM. So in the remix we have the possibility to debug such a transaction by clicking this button here, yes, which just show us the let's say how the transaction is processed by the EVM. Yes, so we have the information how the stack looks like. Yes, what is the state, how the state will just change, and here we have this opcodes. Yes, this is the stack. So basically, as you can see, this is the example of the single opcode. Yes, this swap2, this jump dest. Yes, this is more or less the assembler-like language. Yes, and now of course there's a possibility to write the contract using the opcodes directly, but I don't know anyone who is just willing to do that at the end. But okay, let me maybe just do some steps. So let's do the step forward. Yes, as you can see here, we have the information. We have the let's say picture how the instructions are, let's say, processed each by which. Yes, for example, right now we are just checking the balance of the sender if the sender has enough value to send to the receiver. Yes, and of course we have the information also about the cost. Yes, of each of the opcode. Yes, and, as I mentioned, this is very important. Yes, because we do not want to have the situation that the transfer or the logic will just be executed endless. Yes, so basically each of the opcode is burning some gas available to the transaction. As you can see here, there's the remaining gas which is decreasing by executing single opcode. Yes, so it means that if we end up the transfer still having some remaining gas, it means that the transaction will end up with success. Yes, more or less. If we end up the situation that we have still remaining opcodes to be processed and the remaining gas is less has less value than the next opcode which needs to be executed by the EVM, this will end up with the situation that the transaction will be reverted with the exception out of gas. Yes. So this is how you can just become more familiar with the low-level EVM, let's say, ingredients. Yes. How to. And this is how the EVM internals looks like. Okay, so let me just share again the presentation. Okay. So next slide is about the gas. I mentioned about this gas and its primary role for the contract processing. Yes. And I think that one thing which can be important to mention here is that the gas which we are just referring to, always we just put the values of the gas with the GUI format. This is the one of the you can see the way calculator. Yes, so you just put in the GUI format or the unit. Yes, and the very important stuff here is that the gas, the price of the gas, is something which fluctuates over the time. Yes, so this is the way how the Ethereum is, let's say, self-controlling its, let's say, maybe not performance but the traffic, yes, let's say, in the mempool. Yes, so basically the thing is that if there are lots of the transaction waiting in the mempool, yes, so the normal behavior of the Ethereum is that the gas price will be it's rising through the time. Yes, so it means that the users needs to put a higher gas price in order to transaction will be just picked up by the miners. Yes, so this is the self-organizing, let's say, mechanism then. Because if the price is too high, yes, so the users can just maybe switch or they choose that they maybe would like to wait a little bit longer to pay less gas. Yes, so they are not interested in the fact that the transaction should be picked by the next block, so they're willing to spend less by the cost of the higher, just by the cost of longer waiting for the transactions to be made. Yes, so this is mechanism. So the gas price is the mechanism of let's say self-organizing or just maintaining the performance of the blockchains and congestion of it. Okay, so the next slide, the next step is to the switch. So basically, before the previous slides were more about the basics of the blockchains, yes, then a little bit more details about the EVM itself, yes, and what is under the hood. How the EVM is working, about the opcodes, yes, and now I would like to just switch to the part where I will just give you some information about the dev tools, yes. So the dev tools which are allowing us to build, test, debug, and deploy at the end on the Ethereum blockchain, and exactly the dev tools are the tools which are allowing us to just create these opcodes based on the Solidity source file which we are going to create. Okay, so this is more or less the the landscape of the Ethereum developer. Yes, I know that there's not all of them listed here. However, for me personally, this is the list which is the, let's say, most important, most frequently used now or in the past. Yes, and the tools are in the just for the different purposes. Yes, here. So for example, we have here the mentioning about the Ganache. Ganache, it's a let's say implementation or the implementation of the Ethereum node, which can be run on the local machine. So basically, it is normally used in order to locally test the smart contracts. Yeah, so there is no need by developers to create, even test their smart contracts. For sure, not on the mainnet the first time, and also not on the testnet. Yes, so always you can download the Ganache and just create the private, let's say, test network on your local machine. Yes, and this is the separate component, which more or less looks like this. I'm not sharing the screen. Let me just share maybe. Screen. Okay. So this is how the Ganache looks like. Yes, more or less. So basically, you have the we have the ability of running such a private, let's say, node with the private blockchain. After the start, we have the available accounts. We can just monitor the blocks which are mined by the Ganache itself. Yes, we can just check our transactions which are submitted to that blockchain. Yes, of course, we can just have the contracts list, see the events on the logs. Yes, so this is the Ganache, let's say, purpose of existing. So this is the private node of the Ethereum. I'm sharing the slides. Give me a second. Here. Okay. Then we have the free, let's say, icons of the IDEs. Yes. So I was just before I showed you the Remix. Yes, which is the IDE which is embedded within the Chrome web browser. We can use the, okay, so this is the complete IDE. Yes. And the Truffle and the Hardhat is the more or less the frameworks toolkits, yes, which allows us as a developers to easily code, test, and deploy the smart contracts on different networks. Yes, so these are the two toolkits. Currently, I'm using the Hardhat. Before I was using the Truffle. Hardhat is currently, I believe, the most, let's say, most used one by the developers. I just put also the OpenZeppelin here. OpenZeppelin is a set of libraries which allows to create fast the generic and common, let's say, implementation of some smart contracts like the ERC20, yes, so some NFTs, yes. So basically, there is a set of libraries which can be used in order to speed up development. Yes. Later on, I will just show you what is the difference difference between, let's say, implementing the ERC20 using the OpenZeppelin, and what is the, let's say, number of lines in the code needed to code the implementation of the smart contract without using the OpenZeppelin. The MetaMask here is the Chrome web browser extension, which is pretty much the wallet or Ethereum wallet. Yes, so basically you can just create there the accounts. The accounts means that there will be a separated private key and the public key. Yes, so the public key means that there is an address which can be then accessed by, for example, the Etherscan, or this is the address which, for example, tokens can be sent to. Yes, and also the cryptocurrency like the Ethereum, yes, can be sent to that address. So this is the wallet. Yes, the wallet implementation. In the center of that graphic, we have the two icons. This is Alchemy and the Infura. It's also important to know that, as I mentioned, yes, we as of course, the users of the blockchain, and of course as the developers, which are willing to submit some smart contracts over the network, we cannot reach the blockchain directly. Yes, so we need to have some gateway to that blockchains. Yes, and by gateway I mean we need to have access to some nodes which are connected to the blockchain. Yes, so the both solutions like Alchemy and Infura allows other developers to just create the accounts there and be able to use that accounts to reach the testnets or the mainnets. Yes, in order to submit or deploy or interact with the blockchain itself. Yes, so this is the way. Of course, this is hard, but of course you can just bypass the both providers by having your own nodes. Yes, which are in sync with the blockchain. But it's not easy stuff to do, because recently when I just tried to synchronize, to just to set up the archive node on my, let's say, in my location using some of the let's say spare machine which I have, and at the end, I currently know that it is pretty much not realistic to think about having the node synchronized with the mainnet on your local, on the computer with your in your homes. Yes, because there is one thing which is important in synchronizing the nodes, is the speed of disk and its volume, and the volume of the data. Yes, so you cannot think about synchronizing the nodes using the normal hard drives. Yes, even the SSD is sometimes not enough. So the one thing which right now is able to synchronize also the component which you can use as a storage is this MVE drives, or the volumes which are using the PCI slot. Yes, which are much faster even than comparing to SSD. Yes, and this is not easy. This cheap let's say action, because to synchronize the mainnet, right now you need at least 12 terabytes of the data. So yeah, so the cost of the disk are more or less 20K right now. Of course, you need to have the network connectivity quite fast, and of course the processor, yes, in that machine. So we are just on the other hand, to be honest, we are just need to use this this Alchemy and Infura as a gateway to the blockchain world. Okay, so this is about the landscape of the developers world. So first of all, I would like to mention how to set up the Truffle suite. Yes, basically how I did it. Normally, I use the Visual Studio Code in order to code the smart contracts with usage of Solidity. Yes, along with the Ganache installed as this private node. Yes, and of course the Truffle as an extension or to the Visual Studio Code. So normally what I did is just the installation of the Solidity extension to the Visual Studio Code, then the Truffle for the Visual Studio Code, and truly we are ready to go. Yes, in order to create the smart contracts on the on our machines. Yes. So basically, maybe I will just show you right now the one of the example projects which I have on my machine. Let me again share my screen. Okay, this entire screen. Okay, so oh, come on.
I think you're yeah, exactly.
Yeah, it's okay.
Perfect.
Okay, so basically this is example of I show you just this exactly this very smart contract in this Remix ID, yes, but this is how the Truffle looks like. The working with the Truffle looks like using the Visual Studio Code, yes. So in order to just create such a smart contract, yes, of course we need to create some smart contract. Yes, the Truffle needs to be able to reach the Truffle config file, which just has some important settings here, like the networks. Yes, here I just have the two settings, yes, for the development and the Ganache. And Ganache is just, as you can see, the local host and the port. Yes, so exactly this is the way how I just reach this this Ganache, yes, server. Yes, as you can see, this is the local host and the port number. Yes, so this is how I just define the Ganache private node for the Truffle. Yes. So normally, then the next step is to just create some tokens. Yes, and next step normally it is just put some tests. Yes, you need tests for that. And in order to, for example, test such a smart contract, is what we need to do is just first of all is the running the Truffle. So the Truffle is the suite. We are using the Truffle keyword. Yes. Truffle compile. So let's first of all let's compile our smart contract. Yes. So the compile means that it will just go through all the files within the contract folder and just trying to compile all of them. if anything is wrong, yes, this is the first place where we will be informed that something is wrong with our code. Yes, if everything is okay, next step we can just create some unit tests. Yes, and as you can see, this is the we have the 3 different scenarios here. Yes, where just there's a happy path. Yes. Some assertion to check if it's not working the wrong manner. So in order to test it, so again, Truffle, this time test, yes, this time test, and it should, let's say, run this test area. Oh, sorry, not that. Yes, I need to have, in order to test, it should be the contract should be first of all deployed on the node. So basically, it is now complaining that it's not able to reach that local definition of the node, which is the port 8545. So I need to just point here that I would like to that Truffle will just reach this running Ganache separately. So what I need to do is to just mention about the network in the params. Yes. So by that, I'll just inform that Truffle needs to use this Ganache in order to just deploy my smart contract. Let's see if we have something it would be just visible as a transactions. Okay, now we have the compilation. Okay, as you can see, some transactions were just so first of all we have the transaction which just create the instance of the contract, and then we have some transactions which were used by the tests. Yes. Okay, so this is the more or less how the using the Truffle looks like. Yes, maybe it's worth to mention that that we can debug also such a transaction. Yes, so we have the way of creating the smart contracts. We just have a possibility to test it, but of course it's always worth to have possibility to debug such a transaction. Yes. So let me maybe just deploy this smart contract now, just in the clear way to the Ganache once again. So let me just use some snippet here. Okay, so this is the line. So I just by this I just inform Truffle that I want to just run the migration script. Yes, which is responsible of deploying the smart contract on the network Ganache, which is the private Ganache node, with usage of this Truffle config, yes, file. So right now the smart contract should be compiled and deployed on the Ganache, but this time I would just get the address of that contract as a result of the deployment. Let's wait. Okay, so I have the information that okay, I was having before my token, but it is the replacing, so it is just deploying the completely fresh instance of this smart contract using that address. Yes. So let me just copy that address. And what we can do right now is just using the Truffle console. Ganache. This means that I'm just using the Truffle suite. I'm just running the console, which is more or less connected with the Ganache private node, and I'm now able to just communicate directly with the node, yes, using this console. So let me just check, for example, what is the balance of the account, let's say the first account. So how we will just do that is just the set of the instruction. Let's say it's a contract await my token. So this is the information that I just defined the contract variable. Yes. Now let me just check the contract itself. So, okay, so that variable is let's say initialized by the contract which is deployed on the network on this private Ganache node. Yes. So now having that variable, I can just interact with this smart contract deployed on the Ganache. Yes? So, for example, let's check what is the amount of this token for, let's say, the first account, which is provided by this Ganache. Yes? So we have set of the addresses pre-created by the Ganache after the start. So what I can do right now is to just get the balance of the wait the second contract. Balance of accounts 0. Let's check undefined. Okay, so let's check what is the balance. Set string. And it hangs because I just put the mistake here. Sorry, my fault. I just used the toString with the uppercase T, which was wrong. So again, sorry, I need to just let's just copy that code here. Okay, let's just copy that once again here. So again, I just initialize the variable ti with the token. Yes. Now we have the balance. I can just check the balance associated with the account 0. Yes. As you can see, we have the initial, let's say, value of the balance for the user, the first user. Yes. So let me just maybe try to this time send the balance of for the second account. But first of all, let me just maybe check the balance of the second account. Give me a second. I'll just initialize the variable balance 1 for the account 1. Okay, and now I can just check the balance 1 to string. It is 0. Yes, so this is what we expected. So the account with the index 1 does not possess any tokens. Yes, so what I can do right now is to just send from the account 0 to account 1, I don't know, some number of the funds. Yes, so I just execute the function transfer of that smart contract with the information that the 100 the amount 100 should be transferred to the account 1. Yes, and now I can just check the balance of the account one, but okay, I need to just again ask the smart contract in order to just store the current value in the variable balance one. Yes, so let me just again change the value of the variable using the balance of the account one, and balance one, we have 100. Yes, so this is how you can just interactively play with the smart contract deploy on the Ganache. Yes, instead of course writing the unit tests. Okay, so let me just maybe move to the presentation once again. Okay, so that was the Truffle, yes. Now with the Hardhat, yes. The Hardhat is something which I currently use. And pretty much it's the same approach like for the Truffle, with one single difference, because the Hardhat has the node, the private node, let's say, coming out of the box. So we do not need the Ganache in order to deploy some smart contracts. We can just easily use the Hardhat alone in order to do that. Yes, so basically, in order to play with Hardhat, what we need to do is to just, within the Visual Studio Code, we need to just, of course, enable this extension. This is Solidity. This the icon. This is coming with from the Hardhat, yes, and install these two dependencies, the Hardhat and the Hardhat toolbox. The Hardhat is the general one, which allows you to just use the Hardhat keyword, which is used as a, let's say, CLI tool in order, which is responsible of compiling, deploying, all the stuff connected with the maintenance of the smart contract. Yes, and the Hardhat toolkit is the toolbox, is the package which is allowing you to just basically writing the unit tests, is allowing you to just run some gas optimizers, some enhancements. Yes, and for this one, let me just maybe go also to the Visual Studio Code then once again. So okay, so this is, let me just share. Okay. So this is the how the example project, after running the Hardhat, is constructed, or just it's bootstrapped. Yes. So basically, what we need to do is to just write the keyword npx. So having the empty solution, what we need to do is to just write the npx Hardhat, which effectively will ask about the, as I show you in the presentation. Give me a second. I'll just maybe show that once again using that. This one, okay. So after the npx Hardhat, this is the the CLI response, which are asking us what type of the projects we would like to create. Yes. So at the end, I just choose the JavaScript. Yes, and after choosing that option, we end up with this structure. Yes. So basically, we have the everything what is needed in order to start working with the smart contracts. Yes, even we have the example smart contracts, example scripts which are responsible for deploy such a smart contract to the blockchain somewhere. Yes, and with some unit test, which is also prepared for us, which we can just easily extend for our needs. Yes. A second. Just go to that. And in order to, again, to just compile that and, for example, test, what we need to do is to, instead of just writing the Truffle, we need to just write the npx hardhat compile. And this would result with compiling our smart contract. So this is the first step where we can just be informed that it is okay or not okay from the syntax perspective. Yes. So let me maybe just I do not have anything to compile because I have the artifacts here. Just move that, remove that, and once again compile that. Okay, so I have the information of the compiled one solid file. If I would like to just test it, so I just write the npx hardhat test. Oh, sorry. And as you can see, I do not need here to just refer to any Ganache node. Yes. So Hardhat is responsible right now here to just deploy the smart contract internally, using its own implementation of the node. Yes, and it's just doing executing the test. So it's pretty much easier to use in Hardhat comparing to the Truffle. Yes, so we do not need the Ganache here. Maybe right now I can just maybe show you, because I also this is the, let's say, place where you just we are able to define the network. This, like for the Truffle config, we have the Hardhat config here, yes, and I also put here the Ganache. I can just refer to I can use Ganache, but I also put here the Girly network, which is referring to the testnet Girly, yes. And as you can see, this is something which you should not do at the end coding your smart contracts. You can see here the private key, yes, which is not pretty much safe way of writing the code. And I'm ashamed, but I can maybe show you, what is the dangers here hidden, because I was working with my colleague with sharing the code of the smart contract. We just use I just use my, again, stupid me, but I use my Metamask wallet account, which I just export the private key. I put like this into the file, yes. And as long as we were using the repository, which was in the GitHub, but it was in the private mode, yes. So basically, no one can access that. It was pretty much okay, yes. But for some reason, I don't know, my colleague just changed this visibility of that project from the private to public. And truly, the same private key I use for my mainnet account. Also, I have there, some, fraction of the Ether, but nevertheless, there was something still. And I don't know if you just know, but after the switching the visibility of that project from the private to public, it took 3 minutes, to be honest, in order to some bot just take my private key and deploy some smart contract and just transfer all my Ethereum to that smart contract. Yes. So be let's say aware that having such a private key store in the source code is not very smart. Okay, but this is how the definition of the Girly looks like. Yes. So as you can see here, I just have the info.io. information, put it also. So it means that I'm just using the Infura service in order to reach the Gerli net testnet, yes. And maybe I will show you how the Infura itself looks like. Maybe. So you can easily just create here some accounts, yes. And this some of the number of the requests is free. So basically, if you just create some project, you can just then grab some API key, which then you can use in that configuration. Let's just compare. So this is the API key. So this is the project IDs, which is used by the Hardhat configuration. Yes. So I just showed that how this compile, how this test looks like. But what about deploying that on the Gerli? Yes, testnet. Yes. So basically, this is nothing which is more complicated than again using the npx Hardhat. Oh, I'm just repeating. Sorry. Hardhat keyword, but this time I would like to run script deploy on the network Gerli. Let me just check if it will work. And this is easy as that, yes. So basically, we have now the information that the lock smart contract with some meter on it, yes, an unlock timestamp was deployed to the Gerli on that particular address, yes. And we can just easily check that by copying that address and going to the Gerli at Etherscan. Do I have it somewhere here? No. Etherscan. And let me just check that address. Okay, we have this smart contract. We can just check that the contract is there. This is the lock, yes. And of course, we can just easily, interact with this using the Etherscan also, yes. But this is the proof that Hardhat is able to just deploy the smart contracts on the testnet, along also on the mainnet, of course. Okay, this is all about the usage of the Hardhat, yes. And the last is the plan was to just show you the remix, yes. And the remix is as I mentioned, yes. So you do not need to install anything on the machine. You just need to go to the remix Ethereum.org URL and this ID like that will be open for you, and you are here able to just create smart contracts, yes. Then you are able to compile, yes, that smart contracts using a different version of it, yes. Then deploy it, as I mentioned. So exactly the same steps as in the Visual Studio Code, but with one additional, let's say, adjustment here is that you can change the environment here. Yes, right now I'm just using the embedded, again, the embedded mock of the node. Yes, but I can easily go and check and to be honest, interact with the mainnet event contract. Yes, because I can just use the injected provider Metamask here. Yes, so did I just choose that? Sorry. Let connect. Okay, so let me just check one thing. So now I'm just using my MetaMask, so I need to log in. I am on the girly testnet, yes. Let me just check some account which has some Ether on it. Okay, now I can just change that to the it's not work. Give me a second. Oh, for some reason I cannot change that. This is the remix VM.
Valdemar, as we are
Ending the yeah.
running out of time, so maybe we can just ask if there's any questions for all of what you have seen until now.
Yep. So guys,
We didn't have any questions. I tried to link anything you mentioned during the presentation and the live coding experience. So I tried to post in our chat the sources where can people find more information. But we didn't get any questions during the whole presentation. So I don't know if everything was just super clear or people
it's too easy, probably.
didn't get anything and don't know even what to ask. Remember, there is no stupid questions, so don't be afraid.
Yeah, as I mentioned, I'm not natural born speaker, so maybe that's why I'm just not fit into the the time. But I was just trying also to maybe just mention about the two different type of the smart contract wallets. Yes, so the wallets, yes, the accounts. So to be aware that we have the external account and smart contract wallets, two different types. Yes, and the fact that we have the problem with the smart contract itself. After the deployment, there is a problem which is connected with the immutability of that contract. Yes, because what you just deploy is there. Yes, it's deployed. So basically, you cannot change. So if you just encode the smart contract with a bug, so this bug can be exposed, and it could be used by some malicious actor. Yes, so what can we do with such a thing? Because we just deployed the smart contract, we cannot change it. Yes, how to deal with that fact? Yes, so please remember that answer for that is the proxy pattern. Yes? So basically, in order to deal with such a problem, let's say scenarios, there is a new approach, maybe not new, but the common approach right now, which is connected with the fact that when you just deploy one smart contract, you just deploy the smart contract, now using the proxy pattern means that you are just deploying two of them. Yes, so basically the first contract is just acting as a let's say interface, as a let's say something which will just forward the request to the implementation smart contract, another one. Yes, which is usable because using that proxy pattern, you can still have the same proxy address. Yes, but within that proxy address, you can just point to the new version of the, for example, fixed smart contract. Yes, which will be deployed, of course, on using which will have the different address. Yes, of it. Yes, because each time when you just deploy the smart contract just receive the completely new address of it. Yes, so basically this proxy is using in order to just track the new addresses of the implementation, which allows to still use the address of the proxy, which will just forward the request to the implementation smart contract. It will allows you to just fix the bugs. Yes, or just extend some functionality of it. Yeah. Yeah, so basically that's it. Yeah.
Okay, perfect. We didn't get any questions, so I don't know if should I be worried or not. Hope you enjoyed. Hope you learned something. Thank you for staying until now. Thank you to you, Waldemar, as well, for sharing your knowledge. Of course, the recording of this gonna be available for you after we end the broadcast. If there is any problem with the recording, just contact me. You should have all the information on the chat. So I don't know if you want to say anything else, Waldemar, or we can close.
Yes, thank you very much for attending. Yes, I hope it was not so bad as I can now see in my head. Sorry for all the. Sorry that because truly I just had some diamond at the end. I just. It's a pity that we do not have time, but I would just would like to mention that there is the writing the smart contract is very funny stuff. It could be happy coding, but remember this is kind of dangerous. There is a lot of the actors which are trying to steal your money. Yes, even just searching for the bugs within your smart contracts, but even on the other way, just trying to let's say attack your protocols in the business way. For example, I don't know if you would like to just deep dive a little bit. So just if you can search for the sandwiching transaction, for example, yes, stuff. This is the attack on the let's say business manner. Yes, how to just attack your protocol. And I just at the end just I just thought that I would be able to just show you the front run attack also, yes, in the real example. But sorry, we don't have time for that. But yeah, so front run attacks, yes, and sandwiching.
That was just the first one. We're gonna have like 3 more and several next week. So in 2 next weeks we have next one, and another 2 weeks we are planning another one. Of course, I think you're gonna get all the information from our social media, so keep track of it. And thank you once again. Hope the next one gonna be even better.
I hope, of course.
So thanks once again. Have a good evening, and hope to see you on the next one. Ciao, ciao.
Bye.